Hey there, science fans! Are you ready to dive into the electrifying world of energy? Can you imagine life without electricity? It would be a world plunged into darkness, no lights to brighten our nights, no phones to keep us connected, and no video games to entertain us. Electricity is the lifeblood of our modern world. It powers our homes, schools, and entire cities, lighting up our lives in countless ways. But have you ever wondered where this amazing energy comes from? It's not just magic, it's science. We harness electricity from a variety of sources. Some of the most important ones include wind, water, and fuel. Each source has its own unique way of generating power. Let's dive in and explore these electrifying sources in more detail. Think about all the things you use every day that need electricity. From the moment you wake up to the time you go to bed, electricity is there. Lights, refrigerators, computers, and even your morning coffee maker. They all rely on this incredible form of energy to function. Understanding how we generate electricity not only helps us appreciate its importance, but also inspires us to explore new sustainable ways to power our world. So, get ready for an electrifying journey as we delve into the fascinating world of energy generation. From the spinning blades of wind turbines to the rushing waters of hydroelectric dams and the burning fuels that drive our power plants, there's so much to discover. Imagine a giant windmill, its blades gracefully turning in the wind, capturing the invisible force of nature. That's wind power in action. These turbines are marvels of modern engineering. Wind turbines are like high-tech windmills that harness the kinetic energy of moving air to generate electricity. They stand as sentinels of sustainability. As the wind blows, it pushes the blades, causing them to rotate. This rotation is the first step in a fascinating process. This rotation powers a generator, which transforms the mechanical energy into electrical energy. It's a seamless conversion of natural power into usable electricity. Wind power is a clean and renewable energy source, meaning it doesn't produce harmful pollutants or contribute to climate change. It's a vital part of our transition to a greener future. Wind farms, collections of multiple turbines, are often located in areas with strong and consistent winds, like coastlines or open plains. These locations are chosen for their optimal wind conditions. Some notable wind farms include the Gansu Wind Farm in China, which is one of the largest in the world, the Alta Wind Energy Center in California, known for its impressive scale and efficiency, and the Hornsea project in the UK, which is a testament to the potential of offshore wind energy. These projects highlight the global commitment to harnessing wind power for a sustainable future. Have you ever seen pictures of massive dams holding back enormous amounts of water? These are often hydroelectric dams, engineered marvels that create reservoirs of water, increasing the water's potential energy. When water is released from the reservoir, it flows through tunnels called penstocks, gaining speed and kinetic energy. This fast-moving water then hits the blades of turbines located at the base of the dam, causing them to spin rapidly. The spinning turbines drive generators, much like in wind turbines, to produce electricity. Some of the world's largest hydroelectric dams include the Three Gorges Dam in China, the Itaipu Dam in South America, and the Grand Coulee Dam in the United States. Section 6. Fuel power, burning for energy. While wind and water rely on natural forces, fuel power plants generate electricity by burning fossil fuels like coal, oil, and natural gas. These fuels contain stored chemical energy that's released as heat when burned. The heat is used to boil water, creating steam that drives turbines, which in turn power generators to produce electricity. Although fuel power plants have been a major source of electricity for many years, they also come with drawbacks. Burning fossil fuels releases greenhouse gases into the atmosphere, contributing to climate change and air pollution. Finding cleaner and more sustainable ways to generate electricity is crucial for a healthier planet.
Section 7. Inside a fuel power plant. Heat to electricity. Let's take a peek inside a typical fuel power plant to see how it works. First, fuel is burned in a boiler, producing a tremendous amount of heat. This heat is used to convert water into high-pressure steam. The steam is then directed towards a turbine, causing its blades to spin rapidly. The spinning turbine, connected to a generator, creates electricity through the same principle of electromagnetic induction we discussed earlier. The generated electricity is then sent through transformers to increase its voltage and transmitted through power lines to homes and businesses.
Section 8. The biggest power plants, energy giants. These colossal structures are the backbone of modern civilization, providing the essential energy that powers our homes, industries, and cities. Some power plants are so massive that they can power entire cities or even regions. Their sheer size and capacity are a testament to human ingenuity and the relentless pursuit of progress. The largest power plants in the world, whether fueled by coal, natural gas, nuclear energy, or renewable sources, are engineering marvels that demonstrate the scale of our energy needs. These plants are not just about size, they represent the pinnacle of technological advancement and efficiency in energy production. These plants often employ thousands of people and play a crucial role in their respective countries' energy infrastructure. For example, the workforce behind these giants is highly skilled, ensuring that the plants operate smoothly and safely, contributing significantly to the local economy. The Kashiwazaki Kariwa nuclear power plant in Japan is the world's largest power station by net electrical capacity, capable of generating over 8,000 megawatts of electricity. This plant alone can supply power to millions of homes, showcasing the immense potential of nuclear energy. The Taichung Power Plant in Taiwan, a coal-fired power plant, stands as a testament to the enduring relevance of coal in the global energy mix. It is another example of an energy giant producing a staggering amount of electricity to meet the demands of a densely populated region. Despite the environmental concerns associated with coal, plants like Taichung continue to be vital for energy security. Producing a staggering amount of electricity to meet the demands of a densely populated region. These energy giants are not just about power, they're about progress, innovation, and the relentless drive to meet the ever-growing energy demands of our world.
Section 9. Diverse sources, brighter future. The energy mix. As we've seen, there are many ways to generate electricity, each with its advantages and disadvantages. Relying on a diverse mix of energy sources, known as an energy mix, is essential for a resilient and sustainable energy future. By combining renewable sources like wind, solar, and hydropower with traditional sources like fossil fuels and nuclear power, we can ensure a reliable supply of electricity while reducing our reliance on polluting sources. Transitioning towards a cleaner energy mix is a global effort that requires innovation, investment, and collaboration.
The journey begins. Have you ever stopped to think about how electricity magically appears in your home? It's easy to take for granted, right? You flip a switch and you've got light. But behind that simple action is an incredible journey. A story of energy traveling across miles and miles to power your life. Our journey begins at the source power plants. These mighty facilities are like giant energy factories, working tirelessly to generate the electricity that powers our homes, schools, and everything in between. From there, the electricity embarks on a high-speed adventure, zipping along a network of wires and transformers until it finally arrives at your doorstep, ready to light up your world. Get ready to explore the electrifying world of how electricity travels from power stations to your home. Picture a power plant as a giant energy chef, cooking up massive amounts of electricity. Just like a chef uses different ingredients, power plants have various ways to generate power. Some use coal, natural gas, or nuclear energy to create steam. This steam spins giant turbines, Think of them like powerful windmills, which in turn power generators. Generators are the real stars of the show. They contain coils of wire and powerful magnets. When the turbines spin these coils, it creates a flow of tiny particles called electrons. And guess what? That flow of electrons is what we call electricity. It's like magic, but it's actually science. But that's not all. Some power plants harness the power of nature in even more amazing ways. Hydroelectric plants use the force of rushing water to spin turbines, while solar panels capture energy from the sun, and wind turbines dance with the wind to generate clean electricity. No matter the method, the goal is the same: to create the electrical energy that powers our lives. Once the electricity is generated at the power plant, it's time to hit the road. But instead of cars and trucks, electricity travels on a network of high-voltage transmission lines. Think of these lines as the superhighways of the electrical grid, carrying vast amounts of power over long distances. But why high voltage? Well, imagine trying to send a package across the country through a narrow, winding road. It would take forever. High voltage is like using a super-fast highway system for electricity. By increasing the voltage, we can transmit electricity more efficiently, with less energy loss along the way. These transmission lines are carefully designed to withstand the elements and ensure the safe and reliable delivery of electricity. They are typically made of strong, conductive materials like aluminum or copper, and they are supported by tall towers called pylons. So, buckle up and get ready for a high-voltage ride as we follow electricity on its journey across the grid. When it comes to long-distance travel, electricity often takes to the skies, literally. Overhead power lines, also known as air lines, are the most common method of transmitting electricity over long distances. These lines are strung high above the ground, attached to tall towers called pylons. You've probably seen them before, those tall metal structures that look like giant erector sets marching across the countryside. But why so high? Well, it's all about safety and efficiency. By keeping the power lines high in the air, we reduce the risk of accidental contact and minimize interference with things on the ground, like trees and buildings. Plus, air is a good insulator, meaning it helps prevent electricity from escaping the lines. So, the next time you see those power lines soaring overhead, remember that you're witnessing the aerial highway of electricity, carrying power across vast distances to keep our world running. Section 5. Insulators and pylons, keeping the power flowing smoothly. Now, you might be wondering, if those power lines are carrying so much electricity, why don't they electrocute everything they touch? That's where insulators come in. These clever devices are like protective gloves for power lines, preventing electricity from flowing where it's not supposed to. Insulators are made from materials that don't conduct electricity very well, like ceramic or glass. They are strategically placed along the power lines, acting as barriers between the high-voltage wires and the metal pylons that support them. Think of them as tiny breakdancers, doing the splits to keep the electricity flowing in the right direction. And speaking of pylons, these towering structures play a crucial role in keeping the power flowing smoothly. They are carefully designed and spaced to support the weight of the power lines and withstand the forces of nature, like strong winds and ice storms. They act like the sturdy backbone of the electrical grid, ensuring that electricity can travel safely and reliably across long distances. Section 6. Transformers, shrinking voltage for home use. Remember how we talked about electricity traveling at super high voltages on those transmission lines? Well, that high voltage is great for long-distance travel, but it's way too powerful for our homes and businesses. Imagine trying to plug your phone charger into a power outlet with the same voltage as a lightning bolt. Not a good idea. That's where transformers come in. These ingenious devices act like electrical gear shifters, changing the voltage of electricity. Step-down transformers are used to reduce the voltage from those super high levels down to a safer, more manageable level for everyday use. Think of it like this. Imagine you have a giant fire hose blasting water at incredibly high pressure. You wouldn't want to water your garden with that. A transformer is like attaching a nozzle to the hose, reducing the pressure and allowing you to water your plants without blasting them away. Section 7. Substations, the middlemen of electricity delivery. As electricity makes its way from power plants to our homes, it often makes pit stops at substations. These bustling hubs act like electrical off-ramps, connecting different parts of the grid and directing the flow of power. Substations are where the magic of voltage transformation often takes place. They house those step-down transformers we talked about, gradually reducing the voltage of electricity as it gets closer to its final destination. They also contain other important equipment like circuit breakers and switches, which help protect the grid and ensure the reliable delivery of electricity. Imagine a busy intersection with traffic lights directing cars to different destinations. Substations are like the traffic lights of the electrical grid, ensuring that electricity flows safely and efficiently to where it's needed most. From high voltage to home sweet home, the final stretch. After its journey across high-voltage transmission lines and through substations, electricity is finally ready for the last leg of its journey, to your home. Distribution lines, which are smaller and lower to the ground than transmission lines, carry electricity from substations to neighborhoods and streets. You've probably seen these lines running along streets and alleys, often attached to wooden poles. They act like the local roads of the electrical grid, delivering power directly to our homes and businesses. Finally, electricity reaches its final destination, your house. A service drop, which is a cable connected to the distribution line, brings electricity to your home's service entrance, where it passes through a meter that measures how much electricity you use. From there, it flows through your home's wiring system, ready to power all your lights, appliances, and electronic devices. Electricity's amazing journey, a recap. So there you have it, the incredible journey of electricity from power plants to your home. It's a complex and fascinating process involving a network of power plants, transmission lines, substations, transformers, and distribution lines, all working together seamlessly to deliver the power we rely on every day. Next time you flip a switch or plug in a device, take a moment to appreciate the amazing journey electricity has taken to get there. From those giant power plants to the wires in your walls, it's a testament to human ingenuity and the power of science. Conserving energy, doing our part. Now that we understand the incredible journey electricity takes to reach our homes, it's important to remember that this power comes at a cost. Generating electricity can have environmental impacts, and wasting energy puts a strain on our resources. That's why it's so important to conserve energy whenever we can. By using energy-efficient appliances, turning off lights when we leave a room, and unplugging devices when we're not using them, we can all do our part to reduce our energy consumption and protect our planet. Remember, every little bit counts. By making small changes in our daily lives, we can make a big difference in the long run. The future of electricity, brighter than ever. The world of electricity is constantly evolving with new technologies and innovations emerging all the time. From renewable energy sources like solar and wind power to smart grids that can automatically adjust to changes in demand, the future of electricity is looking brighter than ever. As we continue to explore new ways to generate and distribute electricity, we can look forward to a future with cleaner, more sustainable, and more reliable power for everyone. So stay curious, stay informed, and let's continue to explore the electrifying world of electricity together.
Electricity is amazing. It powers our lights, our phones, and so many things we use every day. Can you imagine life without electricity? It would be pretty different. Electricity is a form of energy that we can use to do work. It's like an invisible force that can travel through wires. These wires are like tiny roads that electricity follows. Electricity is important because it makes our lives easier and more fun. We can watch TV, play video games, and cook food all thanks to electricity. Have you ever seen those big metal boxes near power lines? Those are called transformers. They play a crucial role in delivering electricity to our homes. See, electricity travels best over long distances at very high voltages, but we can't use such high voltage electricity in our homes. It would be dangerous. That's where transformers come in. Transformers are like electrical superheroes that can change the voltage of electricity. They can either step up the voltage to travel long distances or step down the voltage to a safe level for our homes. Just like there are different types of superheroes, there are different types of transformers. Each type has a special job to do. Some transformers are very large and heavy. These are usually found in power plants and substations. They handle the really high voltage electricity. Other transformers are much smaller and can be found on utility poles or even underground. These transformers take the high voltage electricity and step it down to a lower voltage for use in our neighborhoods. So, how does electricity get from the transformer to your house? Well, it travels through wires, of course, but it's not that simple. From the transformer, electricity travels through wires called distribution lines. These lines run along streets and connect to our homes. Before entering your home, the electricity goes through another transformer, usually located on a utility pole or underground near your house. This transformer steps down the voltage one last time to make it safe for use in your home. Section 5. Distribution boards. Your home's electrical hub. The distribution board is a crucial component in your home's electrical system. Once the electricity reaches your house, it goes to your distribution board, also known as a breaker box. This is where the journey of electricity within your home truly begins. This is like the central control center for all the electricity in your home. It manages and directs the flow of electricity to various parts of your house. Inside the distribution board are circuit breakers. These are essential components that ensure the safety and efficiency of your electrical system. These circuit breakers are safety devices that protect your electrical system from overloads. They act as guardians, monitoring the amount of electricity flowing through the circuits. If too much electricity flows through a circuit, the breaker will trip and cut off the power to that circuit. This is a critical function that helps to prevent damage to your electrical appliances and wiring. This prevents fires and other electrical hazards. By cutting off the power, the circuit breaker stops the potential for overheating and electrical fires, ensuring the safety of your home and family. From the distribution board, electricity is distributed to different circuits throughout your home. Each circuit is carefully designed to handle a specific load, ensuring that your electrical system operates smoothly and efficiently. Each circuit powers a specific area or group of appliances. For example, one circuit might power your kitchen appliances, while another handles the lighting in your living room. This organized distribution helps to balance the electrical load and prevent any single circuit from becoming overloaded. Section 6. Safety first, protecting your home's electrical system. Ensuring the safety of your home's electrical system is crucial for the well-being of your family and the longevity of your property. Electricity is powerful and can be dangerous if not handled properly. It powers our homes and makes modern life possible, but it also poses significant risks if not respected. That's why it's important to follow some basic safety tips. These tips can help prevent accidents and ensure that your electrical system remains in good working order. Never touch a downed power line. Downed power lines can carry a high voltage of electricity which can be deadly. Always assume a downed power line is live and dangerous. Don't overload electrical outlets. Overloading outlets can cause them to overheat, leading to potential fires. Plugging too many appliances into one outlet can cause it to overheat and potentially start a fire. It's important to distribute your electrical load across multiple outlets. Be careful when working around water and electricity. Water and electricity are a dangerous combination. Water is an excellent conductor of electricity, so it's important to keep electrical appliances away from water sources. This includes keeping appliances dry and ensuring your hands are dry when using them. If you experience any electrical problems in your home, such as flickering lights, frequent circuit breaker trips, or unusual smells, it's best to call a licensed electrician to diagnose and fix the issue. A professional can safely address the problem and ensure that your electrical system is functioning correctly. Regular maintenance and inspections by a qualified electrician can also help prevent issues before they become serious. Section 7. The importance of reliable electricity. We rely on electricity for so many things in our daily lives. Reliable electricity is essential for our homes, businesses, and communities to function properly. Imagine a world without electricity. Hospitals wouldn't be able to operate, schools couldn't teach, and our homes would be dark and cold. That's why it's so important to have a robust and dependable electrical grid. The system of transformers, distribution lines, and safety devices ensures that we have access to the electricity we need when we need it. Section 8. Electricity, a modern marvel. Electricity is a relatively new invention, but it has revolutionized the way we live. From the first light bulb to the latest smartphones, electricity has powered countless innovations. Think about all the ways electricity has improved our lives. We can communicate instantly with people around the world, travel long distances in comfort, and enjoy entertainment at our fingertips. Electricity is truly a modern marvel that has transformed our world. It's a testament to human ingenuity and our ability to harness the power of nature for our benefit. Section 9. The future of electricity distribution. As technology continues to advance, so too will the way we generate and distribute electricity. We can expect to see even more efficient and sustainable methods of delivering electricity to our homes and businesses. Renewable energy sources like solar and wind power are becoming increasingly important. Smart grids are being developed to better manage electricity demand and distribution, and energy storage technologies are improving, allowing us to store excess electricity for use when needed. The future of electricity distribution is bright, with innovations that will make our electrical grid more reliable, sustainable, and resilient. Section 10. Conserving electricity for a brighter future. While we work towards a more sustainable energy future, it's important that we all do our part to conserve electricity. By using electricity wisely, we can reduce our environmental impact and save money on our energy bills. Here are a few simple ways to conserve electricity. Turn off lights when you leave a room. Unplug electronic devices when not in use. Use energy-efficient appliances and light bulbs. Wash clothes in cold water whenever possible. By making small changes in our daily habits, we can make a big difference in our energy consumption. Section 11. Conclusion. Powering our modern world. Electricity is an essential part of our modern world. It powers our homes, businesses, and industries, making it possible for us to live the way we do today. From the moment we wake up to the time we go to bed, we rely on electricity to power our lives. It lights up our rooms, charges our devices, and keeps our homes comfortable. The journey of electricity from power plants to our homes is a complex and fascinating one. It begins with the generation of electricity at power plants, which can be fueled by coal, natural gas, nuclear energy, or renewable sources like wind and solar. Transformers play a crucial role in this process, ensuring that electricity is delivered safely and reliably. They step up the voltage for long-distance transmission and step it down for safe use in our homes. By understanding how electricity reaches our homes, we can appreciate the importance of this valuable resource and the need to use it wisely. The distribution network, with its intricate web of power lines and transformers, is a marvel of modern engineering. Let's all do our part to conserve electricity and create a brighter, more sustainable future. Simple actions like turning off lights when not in use, unplugging devices, and using energy-efficient appliances can make a big difference. Together, we can ensure that this vital resource is available for generations to come.